Today we are going to present about incident case related to construction site accident in Malaysia. First of all, I would like to introduce myself. My name is Annabelle Grace Jerijo and my matrix number is 07DKA23F20 and 27.
Hello, my name is Helis Chilacharang Stimus, number matrix 07DKA23F2041.
Hi, my name is Aisha Komaria Badria binti alias. My matrix number is 07DKA23F2031.
Hello, my name is Janada Asai, number matrix 07DKA23F2023.
Hi, my name is Raiti binti Jeffrey. My number matrix is 07DKA23 of 2003.
Hello, my name is Shasha binti Muhammad Tasin, number matrix 07DKA23F2023.
The contents in our presentations are introduction, importance of ethical issue and rules of conduct for the professions in civil engineering, background of ethical case, ethical issue involved in that accident, analysis of ethical case, action taken, and the summary or suggestion for the solution.
As you can see on the screen, we are focusing on the KL Eco City pedestrian bridge collapse that happened on November 30, 2016. This bridge was supposed to connect KL Eco City to the Gardens Mall at Mid Valley, but it collapsed during construction. We choose this specific case because it is a perfect example of what happens when engineering ethics are ignored. This wasn't just a technical failure, it involved issues with design validation, site safety, and the protection of workers. One life was lost and several others were seriously injured. Through this presentation, we want to analyze that ethical breach involved and discuss how we, as future civil engineers, can prevent such disasters by following the proper code of conduct. Now, let's look at the importance of these ethical rules in engineering. Moving on to section 2.0, as future civil engineers, we must understand that our paramount duty, as guided by the Board of Engineers Malaysia, is to protect public safety, health, and welfare above all else. This means we must never cut corners or falsify reports just to save time or cost. High ethical standards are what fuel the existential trust between our profession and the society we serve. Next, let's look at ethics and technology. Today, we rely heavily on complex software like BIM and structural analysis tools. While these are powerful, our code of conduct reminds us not to blindly trust technology. We have an ethical responsibility to strictly verify every automated calculation with critical oversight. We are the engineers, the software is just a tool, and we are responsible for the final data. Finally, ethics also include environmental protection and sustainability. We have a professional obligation to minimize ecological disruption and manage construction waste responsibly. By integrating sustainable materials and practices, we ensure that our developments today do not degrade the local environment for future generations.
So we will discuss the background of the ethical case, and this case involves the collapse of a pedestrian bridge under construction at KL Eco City in Kuala Lumpur on 30 November 2016. The bridge was designed to connect KL Eco City with Mid Valley, the Garden shopping mall. During construction, the structure suddenly collapsed and caused a fatal accident involving workers. And the accident resulted in 1 death, 5 injuries, and 1 missing person. Emergency rescue team, including the fire and rescue department, were deployed to the site. And then, investigations were carried out by DOSH and CIDB, and a stop work order was issued to allow a full investigations. According to the mayor of Kuala Lumpur, the possible causes of the collapse include design issues, structural defects, and weaknesses in construction practices and supervision. The project involved multiple stakeholders such as SP Setia as the project developer, contractors, engineers, and DBKL. However, DBKL was only responsible for planning approval and not for technical or safety aspects. This incident raises important ethical concerns, particularly in terms of worker safety, professional responsibility, quality control, and accountability in engineering practices.
In this part, we will discuss the ethical issue involved in the KL Ecocity pedestrian bridge collapse. Overall, this incident highlights several serious ethical concerns in civil engineering practices. For 4.1, there was negligence in ensuring the safety of workers and the public. The incident resulted in one death, several injuries, and one missing person. This shows that safety measures was insufficient for not properly enforced. As engineers, protecting humans' life is a fundamental responsibility. Next, for 4.2, there are issues related to design, validation, and structural integrity. The careless way have been caused by design flaws and structural defects. The design might not have properly checked on or approved. The reflect a lack of professional responsibility in ensuring safe design. Moving on 4.3, there was weaknesses in construction practices and supervision. Monitoring and quality control were not sufficient. In addition, construction may not have followed by required engineering standards. For 4.4, there is also an issue of accountability as a project involved multiple practices such as developers, contractor, engineering, and authorities like DBKL. There have been shifting of responsibility between these parties. However, all stakeholders share responsibility in ensuring the safety and integrity of the project. Finally, for 4.5, there have been non-compliance with professional and regulatory standards. Authorities such as DOSH and CIDB were involved in investigation engineering are required to follow laws, codes, and professional guidelines.
For this section, we will analyze the KL Ecocity Bridge collapse from an ethical perspective. Firstly, there is a clear failure in prioritizing public and worker safety. The incident resulted in fatalities and injuries, which indicates that safety measures, risk assessment, and hazard control were not properly implemented. Secondly, there are issues related to design and structural integrity. The collapse may have been caused by design flaws or structural defects. This suggests that the design was not truly checked or properly approved. Such failure reflects a lack of professional competence and does not meet the standard set by the Board of Engineers Malaysia. Next, there were weaknesses in construction practices and supervision. Monitoring and quality control were inadequate, and construction may not have followed approved plans and specifications. In addition, there are issues with accountability as the project involved multiple stakeholders such as developers, contractor, engineers, and authorities. Responsibility may have been shifted between parties, which reduced transparency and ethical integrity. Finally, there is possible non-compliance with regulatory and ethical standards. Authorities such as DOSH and CIDB were involved in the investigation, indicating that proper procedure may not have been fully followed. Overall, this case shows multiple ethical failures including safety negligence, poor design verification, weak supervision, lack of accountability, and non-compliance with regulations.
Moving on, 3.0 Action taken. For post-accident actions, it took legal enforcement, contractor charged under CIDB Act 520, Section 34B, fine for negligence and failure to ensure site safety. Second, forensic investigation. DOSH used computer simulations to pinpoint design flaws, specifically loading eccentricity caused by the bridge's curve. Next, policy reform. Accelerated the OSH-MP 2020 preventive culture and the tightened CITP enforcement regarding safety and professionalism. And legal precedents set strict court standards for liquid debt as certain damages LAD and extension of time EOT in structural failure cases. Continuing, 6.2 Engineering recommendation. Independent peer review, mandatory category third checks by an external firm to validate simulations and catch design blind spots. Real-time monitoring, SHM. Use strain gauges and thermistor to monitor stress and heat linked to an automated evacuation alarm system. Temporary work oversight. Appoint a specific professional engineer, PETW, to treat scaffolding and shoring with the same rigor as the permanent build. Fail-safe redundancy. Design connection to allow load redistribution, ensuring a single bolt of bearing failure doesn't cause a total collapse.
From this case study, we can see that safety was not prioritized, which led to fatalities and injuries. The solution is to strengthen site safety systems, provide regular training, and give engineers full authority to stop unsafe work. Next, weaknesses in design validation show the need for independent peer review. Complex structures must be checked by external experts to minimize risk and uphold professionalism. Poor construction practice and weak supervisions also contribute to the collapse. Structural healthy monitoring with sensors should be introduced to detect stress or heat before failure happens. Another issue is accountability. Stakeholders try to shift blame instead of owning responsibility. Clear accountability reports must be mandatory to define each party's role in ensuring safety and quality. Finally, non-compliance with standards and ethics reveal serious weaknesses. Projects must strictly follow CIDB Act and DOSH guidelines, while embedding ethical principles in every technical decision. This way, public safety can be prioritized and trust in civil engineering restored.